Okay, so we're going to start off today solving systems of equations by graphing. So a system just means more than one. So if we have 2 or 3 equations, that's a system. And equations means that it has an equal sign. So if it doesn't have an equal sign, it's called an expression. So these are equations. There's only 2 of them, so we have a pretty small system. And we're going to try to solve it by graphing so we can kind of see what a solution looks like. So we should know some ways of graphing from previous classes, and one of the ways is intercepts. So one of the ways that you can graph is to find your intercepts. Intercepts are the same thing as finding your zeros. They're where it crosses the x and y axis, so we can plug in 0 for the different variables. So let's go ahead and try that with the first one. I have 3x plus 2y equals 9. So I'm going to sub in 0 for my first variable. So 3 times 0 plus 2y equals 9. And I'm going to solve. So y is going to equal 9 over 2. Now I'm going to plot that. I have a point. I have 0, 9 over 2. It's a weird point. I have a fraction. But 9 over 2 is 4.5, so I'm just going to put it somewhere between 4 and 5. 3, 4, so there, that looks about halfway between 4 and 5. And I'm going to find my other intercept, so I'm going to have 3x plus 2y, and change my y to a 0, so 3x plus 2 times 0 equals 9. 3x equals 9, so x is going to equal 3. So I can plot that. I have a second point, 3, 0. So I'll put that on my x-axis. X-axis is your horizontal, y-axis is your vertical. Now that I have the intercepts, I can draw my line. So I have one line. This is a system of equations. So I have 2 lines. So I already plotted my one. I'm going to go ahead and now plot my second. So let's see, I could plot this by intercepts again. That's how we're going to do the rest of these. But for those that remember y equals mx plus b, I can also plot this using slope and y-intercept. When it's solved for y, and it's in this form, this is solved for y, so it's a pretty easy one to do it with. B is your y-intercept. So in this case, my y-intercept is -1. M is your slope. So in this case, my slope is 4 over 1. Slope is rise over run, so we always want to write it as a fraction. So y-intercept is -1. So I'm going to put that on my graph first and use my slope to get to my next point. So let's see, it'll be up 4, so 1, 2, 3, 4, it's up 4 over 1, so over 1. So I'm going to draw that line. So this question said to solve this system of equations by graphing. So when we're solving for something, we're usually solving for an x or solving for a y, but then, since this was a system of equations, it had both an x and a y. When you have both an x and a y, that means that we're solving for a point. So we're looking for the one point, or we'll find out later, maybe more than one point, that works for both equations. So we can estimate this. It looks like my x for this is 1, and it looks like my y for this is 3. So I can go ahead and say this point is 1, 3. I can check this. How would I check it? I can go ahead and sub the point into both equations and see if it works. 3 times 1 plus 2 times 3. Does that equal 9? Yes. Can sub it in my other one. 3. Does that equal 4 times 1 minus 1? Yes. So this is the correct solution to systems of equations. So let's try another one. Let's try the second one over here. I'm just going to do this by intercept, so I'm going to go ahead and find my first 0, so I'm going to sub 0 in for my x, and try to find what my y is. If I sub 0 in for my x, that means I'm putting 0, so I'm going to write this one out, 2 times 0 minus 6y equals 12, so y is going to equal -2. Can find my other intercept, so I'm going to sub 0 in for y. So I'll get 2x minus 6 times 0 equals 12. So x equals 6. So I have a point 6, 0. So I can plot those. So let's see, 0, -2 would be down 2 on the y. 6, 0 would be over 6 on the x. I'm going to draw another little tab. I only went out to 5. Okay, so I can do that with my other equation. 0 for my x. If I put 0 in for my x, I can kind of do this in my head. If I put 0 in for my x, the x term is just going to go away. That's going to be a 0. So I have 3y equals negative 6. So my y is going to equal negative 2. If I put 0 in for my y, that y term is going to go away. So that x is going to be negative 6. Okay, so I'm going to go ahead and plot this. So let's see, my y is at negative 2, so that didn't move. My x is at negative 6. Kind of weird that's completely reflected the other way. And again, I'm going to connect my points. So now I'm looking for the point that works. That point that works is that 0, negative 2. And I can check, is that the solution to this system of equations? And it should be. Okay, so let's go to my last one. It looks like it's going to be a little harder to do by intercepts. I can continue doing it by intercepts, or I can try the slope y-intercept form. I'm going to continue trying to do it by intercepts and just see what happens. So let's see, my first equation, if I put 0 in for x, then that means that x term is basically going to go away. So I'm going to have 3y equals 4. So y is going to equal 4 over 3. If I put 0 in for y, then that y term is going to kind of go away, and I'm going to get 4 over 6. 4 over 6 should simplify to 2/3. So let's see, how would I graph 4 over 3? Well, 3 goes into 4 one time, so it's somewhere between 1 and 2. And it's between 1 and 2 on the y-axis. Ignore that I just did that. Here, we'll exit out. There we go. 2/3, 3 goes into 2 no times, so that's got to be between 0 and 1. So I have this, maybe. Kind of guessing, so maybe. Let's try the other, see if I can find the intercepts. So again, I'm going to put 0 in for x. If I do that, this x term is going to basically go away. I'll get y equals 7. Then I'm going to put 0 in for y, which means that y term is basically going to go away, and I'm going to have 7 over 2. So 0, 7 would be up 7. I only went up to 5, so let me draw 2 more. 7 over 2, 0. 2 goes into 7 3 times, so it's going to be a little over 3. 3.5 to be exact. So I'm going to draw that line. Now we can see the problem with solving these things by graphing. A, I'm not really sure if these points are accurate because it's hard to draw 2/3 and 4/3. B, I have no idea if these ever actually meet. They could. Maybe I drew them at the wrong slope, and maybe they meet way down in the negatives. Maybe they meet way up in the positives. But because it's me drawing, don't have a ruler, and I'm not that great at drawing anyways, I'm not really sure. So currently I'm going to say that they don't meet, but we're going to see if we can solve these another way on the next set.